Hello again. This video contains the solutions for the 6-7 multiple choice practice. This is rectilinear motion using integrals. Okay, first problem. A particle moves in a straight line with a velocity v of t equals t squared. How far does the particle move between t1 and t2? Well, we know that we can do that by finding the antiderivative of velocity. Right? How far does a particle move? The antiderivative of velocity is position. So the antiderivative of t squared is t cubed over 3 from 1 to 2. That's 8/3. Plugging the 2 in, minus 1/3. That's 7/3. Number 2, the acceleration of a body is given by acceleration equals 8 minus 6t. If the velocity of the body is 25 at t1, that's like giving us a point on the velocity. And if s of t is the distance, then what is s of 4 minus s of 2? Well, to get from acceleration back to position, we have to first find velocity. So velocity is the antiderivative of acceleration, minus 6t, which is 8t minus 3t squared plus c. Now, we're going to have to find the c, but we can do that using this. I told us that at t equals 1, the velocity is 25. That means if I plug 1 into this, I get 8 minus 3 plus c, that's supposed to be equal to 25. And that gives us a c of 20. So if c is 20, that means the velocity function is 8t minus 3t squared plus 20. So to find the displacement from s of 4 to s of 2, we can find the antiderivative again, this time of velocity, since we know what it is now. 8t minus 3t squared plus 20 dt. And the antiderivative of that is, sorry, it's a little crowded here. Antiderivative of 8t is 4t squared. Antiderivative of 3t squared is minus t cubed plus 20t from 2 to 4. And let's see if we can plug those numbers in there and get an answer. Sorry, I'm so crowded here. So let's see, plugging 4 in here, I get 4 times 4 squared. That's 4 times 64 is, no, sorry, 4 times 16 is 64, minus 4 cubed is also 64, plus 20 times 4 is 80. That's what we get when we plug in the 4, minus, and we get when we plug in the 2. 2 squared is 4 times 4 is 16, minus t cubed. 2 cubed is 8, plus 20 times 2 is 40. So let's see, the 64's cancel out, so we have 80 minus, let's see, 16 minus 8 is 8 plus 48, so 80 minus 48 is 32. That's D. Okay. Particle moves on the curve y equals natural log x, so that the x component has a velocity. So focusing on the x component here, has a velocity x prime. That's the derivative of that would be the same as velocity, and is equal to t plus 1. So we could write that as the same as the velocity as t plus 1. At time 0, the particle's at the point 1, 0. And that's actually, they didn't have to tell us that, right? That's a point on this curve. So at time 1, the particle is at the point. Okay, so we need to find what the x displacement is from 0 to 1. So that would be from 0 to 1, the velocity curve, that's the velocity curve, is t plus 1 dt. So that's, antiderivative of t plus 1 is t squared over 2 plus t from 0 to 1. And that's equal to, let's see, plugging the 1 in here, that gives me 1/2 plus 1, 3/2 minus 0. So that means the displacement from 0 to 1, that's the displacement. Okay? Now, you need to look back at where it started. It started at the point 1, 0, and the displacement from 0 to 1 is 3/2. So that means now it's going to be at the point, it's been displaced 3/2 from this x-coordinate. So that means it's now at 5/2. So we had to go back and look at where it started, right? Comma, and then the y-coordinate would be whatever you get when you plug in 5/2 would be natural log of 5/2. So that's C. Notice that this choice E is what you would get if you forgot to add the initial position in, right? This is the displacement. That's just how far it went, but that's how far it went from here. Next problem. Velocity of a particle moving on a line at time t. Here's the velocity. How many meters did the particle travel from time 0 to time 4? Okay, so that's the antiderivative from 0 to 4 of the velocity function, and the antiderivative of 3t to the 1/2 is 2/3 t to the 3/2 times the 3. That would give us 2t to the 3/2 plus the antiderivative of t to the 3/2 is t to the 5/2, and then times 2/5, the 5s would cancel out, so that would be 2t to the 5/2, 0 to 4. Plugging the 4 in here, 4 to the 3/2, that's the square root of 4, which is 2, to the 3rd power is 8, times 2 is 16, plus 4, plugging that in here, the square root of 4 is 2, to the 5th is 32, times 2 is 64, and minus, what do you get when you plug 0 into this? You just get 0. So 16 plus 64 is 80. D. If the position of a particle on the x-axis at time t is negative 5t squared, that's position, then the average velocity of the particle, this is a different question now, average velocity. Average velocity is just position, that would be x of 3 minus x of 0 minus 3 over 3 minus 0. This is average, means just you're actually finding a slope. So plugging 3 in here, we get 3 squared is 9, that's negative 45 minus 0 over 3 minus 0, that's negative 15. That's average velocity. When you see average anything, that means you're actually finding a slope. If the velocity of a particle moving along the x-axis is this, and if at t0 its position is 4, so that's giving us a point. Then at any time its position is, so this is just giving us a way to find the c. So the antiderivative of this velocity is t squared minus 4t plus c. So right off the bat we can cross off those, right? It's going to be t squared minus 4t plus whatever the c is. And if I plug 0 into this, I know that 0 squared minus 4 times 0 plus c is supposed to be equal to 4. So the c is 4. So that gives us c. Here's the answer if you forgot to do the c at all. And I guess this is just a sign mistake with the c. Here at t0 times 0, a particle starts at rest. That means velocity at 0 is 0 and moves along a line in such a way that at time t, its acceleration is 24t squared, feet per second squared. Through how many feet does the particle move during the first 2 seconds? Well, I'm going to have to get from acceleration back to position. So, see, the velocity function is the antiderivative of acceleration. The antiderivative of this is 8t cubed plus c. And they told us that at velocity 0, at time 0, the velocity is 0. So plugging that in, that gives us a c of 0. So the velocity function is just 8t cubed, right? The c turned out to be 0. They did give us a point, and it just turned out that the c was 0. So that means that the position during the first 2 seconds would be the antiderivative from 0 to 2 of the velocity. The antiderivative of 8t cubed is 2t to the 4th from 0 to 2. And plugging 2 in there, we get 2 to the 4th is 16 times 2 is 32 minus 0. That's 32. A particle moves along the x-axis so that at any time t, its position is given by this. For what values of t is the particle at rest? That's a little bit different question. That's asking when is the velocity equal to 0. So slip this one in here. This is actually not an antiderivative question. This is more of a derivative question. So the velocity of this is the derivative of this. So here's a little reminder about how to use the product rule, right? That's t times e to the negative 2t. So the derivative of this would be the derivative of the first t, which is 1, times the second, plus the first, times the derivative of the second. The derivative of e to the negative 2t is e to the negative 2t times the derivative of what's inside. Okay, so we need to set that equal to 0. The particle is at rest when the velocity is 0. So let's see, that's 0 is equal to e to the negative 2t minus 2t times e to the negative 2t. And we've seen this kind of thing before. Factoring out the e to the negative 2t gives me 1 minus 2t. And that can't be equal to 0. So the only time it's at rest would be when this factor is 0. And that happens at t equals 1/2. So t equals 1/2 only. So answer C.